Solve problem on transverse vibration.
Let us understand the concept of transverse vibration with the help of diagram. We will consider one flexible rod of length L. One end of the flexible rod is fixed and at the free end mass M is connected. Now this rod is in the form of cantilever beam. Now when the vibration in this system is taking place, then the particles of this mass M will vibrate in this upward and downward direction. And where is the axis of this rod? So axis of this rod is this horizontal line. So if we observe, the vibration is taking place in the perpendicular direction to the axis of the rod. So we can say that this type of vibration is the transverse vibration. Now we will understand the different formulas related to transverse vibration to solve the problems. So for that, now we will consider here the mass M is moving in the downward direction. So deflection in this mass M is known as delta. Where we will consider the mass of this rod is negligible. But there is the modulus of elasticity E for this rod material. So we can say that modulus of elasticity in Newton per meter square. So this is the standard unit for E. So I will consider it is related to rod material. Then there is the transverse stiffness K in this rod. That is also in Newton per meter. So standard unit is Newton per meter and it is related to rod. So I will write here as a K. So here this stiffness K is related to the spring stiffness K. So we can say that the spring mass system and this rod and mass system are equivalent to each other. So we can consider this rod is flexible with stiffness K and we can say here that this system is equivalent, that is this rod is equivalent to spring with stiffness K, and at the free end mass M is connected, so at the lower end mass M is connected. So these two systems are equivalent to each other. Now next is I. So I is the mass moment of inertia at the rod cross section XX. So we can take any cross section XX. This rod is circular and therefore at this cross section XX we can consider I as a mass moment of inertia. So I will write here as a I and unit is meter raised to 4. Now how we can write the formula? So we know that for cantilever beam deflection delta is equal to WL cube by 3EIXX. Now what is this W? W is equal to mg. So m is present here. Now we can write the stiffness K for this cantilever beam is equal to W by delta. So when we put the value of delta, then this W is getting cancelled and we can write here 3EIXX by L cube. Now this is the formula for stiffness K. Now we will move from this system to the spring mass system. Now for this spring mass system, here is the stiffness K, here is the mass M. Now if we write the equation of motion for the spring mass system, that is the motion of M is in the downward direction here, then what is this equation of X? So X is the linear displacement. So we can write here X double dot plus K by Mx is equal to 0. So this equation of motion is applicable to this system. Now these two are equivalent to each other. So we can also write X double dot plus omega n square X is equal to 0. So from this we can write here omega n is equal to under root of K by n. Now we can put the value of K from this system. So this is the value of K. So when we put here under root of 3EIXX divided by, here M already exists for omega n, so we will write here ml cube. Now this is the formula for omega n. So we have to consider this formula to calculate omega n. Now how to find out the natural frequency Fn? So we have formula Fn is equal to omega n by 2 pi. So we have to simply write for the transverse vibration this under root term divided by 2 pi and it is the formula for the natural frequency.
Given question, a uniform rod of mass m is supported as shown in diagram. Determine the frequency of resulting motion.
Let us understand given system. Uniform rod of mass m is given, which can rotate about the center O1. While for each section, length is also mentioned as L by 2 and for other section is L by 2. At one end of this rod is spring with stiffness K is connected. Now we have to find out the equation for the frequency for this system. So to find out the frequency for this system, we will consider this system is getting displaced by an angle theta about the center O1. So we have to first show this, the displacement of this rod. So I will show here because from the center it is getting displaced through an angle theta. So we have to show this by drawing of the line passing through the center. So here is the angular displacement theta. We have to show. So same angular displacement theta is taking place on the opposite side. Now while this angular displacement theta is taking place about the center O1, then for each of these end there is the linear displacement x. So we have to show this. So here is the original position for the axis of the rod and this is the final position of the axis. So this end point will move through a distance x. So we have to show. Now this center is known as O1. I will show here original position as a point A and final position as a point B. So here is the triangle O1AB. Now from this triangle we know the A to O1 is L by 2. So how we can define this x in terms of theta? So we know that x is equal to this L by 2 sine of theta. But this theta is very small. So we can say that x is equal to L by 2 theta. So this is the relation in between x and theta. Now because of this angular displacement theta in the downward direction for this portion, in the same direction accelerating torque develops. And what is this value for the accelerating torque? So it is given that the mass of this rod is m. So accelerating torque we have to show in the same direction of the displacement, that is in this direction, that is I into theta double dot, where I is known as mass moment of inertia of this rod and theta double dot is the angular acceleration. So it is taking place in the same direction of this theta because angular displacement is taking place in the downward direction. So we have to show in the same direction of this accelerating torque. So it is also known as accelerating couple. Now here the spring is getting compressed in the downward direction. So because here spring with stiffness K is connected to this end, so the spring will be getting compressed through a distance, that is the linear displacement is x. So spring is getting compressed by x. So in the opposite direction of this compression, spring force activates. So we have to show this spring force, that is Fs. So in the opposite direction, so we will say Fs is equal to, so how we can define this spring force? That is stiffness multiplied by this compression x, that is Kx. So we have to show this Fs is equal to Kx. Now this is the free body diagram of the system. So from this free body diagram we can write the formula: accelerating couple is equal to summation of external couple. So this is the force which will act in the upward direction. Now we have to find out the summation of external couple, that is couple for this force Fs. So if I move the compass in the direction of Fs, then about the center O, then how we can write the couple? That is Fs into L by 2. And what is the direction? That is in the clockwise direction. And what is the direction of this accelerating couple? That is in the anti-clockwise direction. So for anti-clockwise direction we will consider negative sign, and for clockwise direction we will consider positive sign. So accelerating couple we will write here minus I theta double dot is equal to summation of external couple. So external force is Fs. So here it is in clockwise direction about O1, because if we move the compass about O1 in the upward direction, then there is clockwise direction. So here Fs into L by 2, that is Kx into L by 2. So we will write here minus I theta double dot is equal to Kx into L by 2. Now we have to put the value of x in terms of theta. So here x is equal to L by 2 theta, so we have to put here. So I theta double dot plus k L square by 4 theta is equal to 0. Now what is the value of I for this rod? So for this rod I is equal to ml square by 12. So this is important. Value of I for this rod is ml square by 12. So we have to put this value for this I, and we have to simplify this. So coefficient of theta double dot is I. So we will divide all this equation with I. So in the denominator there is theta double dot plus kl square by 4 divided by I. So instead of I will write here ml square by 12. Bracket complete theta is equal to 0. So here L square is getting cancelled. So here 3. So if we simplify this, then 3k by m. So we can write here theta double dot plus 3k by m theta is equal to 0. So now we will write the equation of SHM. X double dot plus omega n square x is equal to 0. So we can write here omega n is equal to under root of 3k by m. So how we can write the equation for the frequency? That is Fn is equal to omega n by 2 pi, that is 1 by 2 pi under root of 3k by m. So this is the final answer.